Okay, let's keep going then. Okay, so this will be 1 minus 2, minus x squared, thank you, over 1 plus x squared squared, right? Okay, now, anytime the derivative is 0 or undefined are interesting times to us. So we want to set both the top equal to 0, and we also want to set the bottom equal to 0. Always do this. Okay. At the top, my x will equal 0 at 1 and negative 1, right? And at the bottom, my x is never going to equal 0, so this one has no solution. But it's okay. We should always attempt it anyway. So always attempt both the top and the bottom equaling 0. Because something funky happens when your derivative is undefined. Remember, it could be a cusp, a vertical tangent, or a discontinuity, and you don't know which one, so you got to set the denominator equal 0. Okay, now we do a number line. Label your number line. Always got to label. Put your critical values on here. We'll talk about critical values later, but there are these 2 points. We'll put our critical values on. And then we're going to test numbers in these 3 sections just to see what the first derivative is doing. Because we know at these locations it changes, it hits 0. So when it hits 0, something funky is happening. It might change from negative to positive. So I'm going to choose a number a little bit less than negative 1, negative 2. Plug that in here. All I really care about is whether it's going to be positive or negative. So the top of this one is going to be negative, right? And then the bottom's always going to be positive. So this is going to be a negative. Let's choose 0 in between here. So that's positive on the top, and it's always positive on the bottom. So this is positive. And then x equals 3.
Negative 2 negative?
Negative 2 squared, and then a 1 minus, yeah. So this is 1 minus. So this is negative, and that's still positive. So this is negative. Okay? So that's what f prime is doing. And then below here, if you want to, we can do a little bit of what f is doing. F is, if f prime is negative, then f is going down, then up, and then down. So we know our intervals of increasing and decreasing now. So we are increasing from negative 1 to 1. Remember, we're not going to include the end points because they're constant at those points. And we are decreasing from negative infinity to negative 1 and 1 to infinity. And if it says justify your answer, you would want to say because f prime is positive for the increasing part, and for decreasing you would want to say because f prime is negative. Okay, but that's your justification. As long as you do the chart, then you can say because f prime is positive and f prime is negative. Okay, questions? Pretty easy, right? I think most of you have done this a little bit before, right? Pre-calc honors people, have you done this at all? Yeah, a little bit, okay. Okay, cool. Now let's talk about concavity. Now concavity is if the second derivative is positive, the graph is concave up, and if the second derivative is negative, the graph is concave down. Also, if the first derivative is increasing, then the second derivative is positive and the graph is concave up. First derivative decreasing, second derivative is negative, the graph is concave down. So there's a link between all 3. Anyways, what's the second derivative of x squared?
2.
Just 2, right? The first derivative is 2x, the second derivative is 2. So I have 2 here. Okay, is my second derivative all positive or all negative? It's always positive, right? Which would mean that my original would be always concave up, which it's a quadratic, and quadratics are always concave up, right? So, and then that would mean that my first derivative is always increasing, right? So my first derivative is always increasing, my second derivative is always positive. So there's always a link between the three graphs. Okay, concavity is mostly dependent on where the tangent line is. So if you've got a concave up function, I shouldn't have written in this little area. But if you got a concave up function, then every single tangent line you draw is below your curve. That's how you know it's concave up. Because sometimes it's hard to figure out like whether I'm concave up or concave down. If you draw a little tangent line, it should be underneath the curve. That means that it's concave up. Anything that's concave down, all your tangent lines are going to be on top of the curve. So all concave down graphs have tangent lines on top of the curve. So if I drew a graph like this, if I drew a tangent line here, I would know I'm concave down here. If I draw a tangent line right here, I know I'm concave up right here. Okay, so you know it switches like at some rando point right here. Okay, this rando point where it switches from concave down to concave up is called a point of inflection or an inflection point. So any inflection point happens when your second derivative changes. F double prime has to change from positive to negative. Okay, it's got to change. Just because it equals 0 doesn't mean it's inflection point. Or negative to positive. If it doesn't change direction, then there's no inflection point. Okay? All right, let's do example 2. Let's do concavity and inflection points. So, I'm going to expand this so I don't have to do product rule. X to the 2/3 minus x to the 5/3. F prime is 2/3 x to the negative 1/3 minus 5/3 x to the 2/3. F double prime is negative 2/9 x to the negative 4/3 minus 10/9 x to the negative 1/3. Okay, yuckies. Let's write this as a fraction. Negative 2/9 to the 4/3 minus 10/9 to the 1/3. Let's combine them. So you want to get one singular fraction before you start doing things. So I'm going to multiply this one by an x on top and on the bottom. That way I can get common denominators. And I would have negative 2 minus 10x all over 9x to the 4/3. Good? All right, again, we have to set the top equal to 0 and the bottom equal to 0. So x equals 0 on the bottom, and negative 2 minus 10x equals 0, and x equals 1/5. Weird number. Okay, F double prime, number line. Yeah, thanks. Negative 1/5 and 0. Okay. All right, pick a number less than -1/5. Okay, x equals -1. So -1 would make positive, right? Over positive. Because -1 to the 4th would make it positive, and even if you cube root, so that's positive. Oh, gross. -1/10 maybe? 2 plus 1 is negative over, this is positive. That's negative. 3, negative. Positive, negative. Okay. So, would we say, oh, okay. Now, let's go f prime. F prime, if f double prime is positive, negative, negative, then what's f prime doing? Increasing, decreasing, increasing. Oh, man. Decreasing. Okay. Huh? Yeah, white out. Magic eraser. And then what's f doing? If f prime is increasing, what's f doing? And positive. Concave up, concave down, and then concave down. Okay. Good. So, we could say we are concave up at -infinity to -1/5, and we are concave down from -1/5 to 0, and then 0 to infinity. You gotta go. Not something funky's happened at 0, so you don't have to say. You can't say it at 0. We've got a point of inflection where at the -1/5, because it goes from concave up to concave down. So we say -1/5, comma. Oh, and then you have to plug in -1/5 in here. 2/3. Just write it. It's too hard to compute on your own. So we just write the whole y with 1/5 plugged in here. Oh no, I plugged it into the derivative. You guys didn't stop me. I hate you so much. Why didn't you tell me? How dare you? Now I gotta erase all of this stuff. It's all because of you. Did you erase yours? Or did you do yours right and not tell me that I did mine wrong? How rude. Okay, got it? Yeah? All right. This is all review. Relative extrema. We've got two tests. The first derivative test and a second derivative test. So a relative max or a local max happens at the top of a hump or the bottom of a hump. So this one has 3 relative extremas. Okay, now what you do is you find a critical point. A critical point is where either the derivative is 0 or not defined, and then you test. And if your first derivative changes from negative to positive, you've got a relative min, right? And if your first derivative changes from positive to negative, then you have a relative max because your original is changing from decreasing to increasing and increasing to decreasing. The maximum and minimum values are the y values, so make sure if it asks you what is the maximum, you say the y value. not the x value. The x is where it happens. The y is what it is. Okay, so find the relative extrema. First, we take the first derivative, and you set it equal to 0. So we get negative 6x squared plus 6x equals to 0. Factor out a negative 6x. X minus 1 equals 0. X equals 0 and 1. Number line. F prime. 0, 1. Then you can either test your numbers, or you know that the derivative is a parabola pointing downwards. So if it's a parabola pointing down, then it's going to go from negative to positive to negative. If you want, you can do it that way. Okay. That means if f prime is doing that, my f below is doing decreasing, increasing, decreasing. Which means that at 0, I've got a min. And at 1, I've got a max. Okay? Yeah. All right. So we can say relative min at 0, comma, plug in 0, 0, and a relative max at 1, comma, 1. Convenient. And if you wanted to justify your answer, you would say because f prime goes from negative to positive, and then because f prime goes from positive to negative for relative max. Questions on that? Yes?
Like the previous question, like what happens when it's 2 negatives?
2 negatives. This one?
Like the one where you had like.
Oh yeah, I'll show you. What was the equation of that thing? X to the
2/3. Then 1 minus x.
Okay, weirdo graph right here. So, right here, it's concave up until we hit negative 1/5, right? And then right here, we switch to concave down. And then something odd happens here at 0, but I stay concave down. You see it? So like, some funky thing happens where maybe you change from decreasing to increasing, but my concavity didn't change. But something weird did happen, even though it goes negative, 0, negative. That with the see the second derivative doesn't exist there. There is no concavity at that point. Okay. All right. Cool. Next, second derivative test, which most of you will be like, well, why do I have to learn second derivative test if I can just learn first derivative test, right? Well, you have to. Because second derivative test must be used for implicit functions. Well, not implicit functions, because they're not functions, because they don't pass the vertical line test. But they must be used for implicit equations, because think about an implicit equation, like x squared plus y squared equals 4. That's an implicit equation, and that's the equation of a circle, right? That no longer works on a straight vertical line. I can't draw from left to right because I come back around, right? So because I don't work on a straight line for implicit functions, I can't do a number line test for implicit functions, which means I can't do the first derivative test because the first derivative test is completely dependent on me being able to do a number line and test values on either side. But right here, it might go, I can't go left, middle, right because I have nothing on the right side of it. Are you with me? Yeah? Okay, maybe not, whatever. Just listen to me. Okay, so second derivative test means that I don't need to test anything on the left and the right. I just want to know about that one point in particular. So what it says is if your first derivative is 0 and your second derivative is negative, this is negative, right? If your second derivative is negative and your first derivative is 0, then you have a concave down graph, right? Your second derivative is negative, means it's concave down. Your first derivative equals 0 means you have to have a horizontal tangent line, and the only place that I can have a horizontal tangent line and a concave down graph is where I hit a maximum. Similarly, if my second derivative is positive and it's concave up and my first derivative equals 0, the only point I could be at would be a relative minimum. Okay, so that's second derivative test, and that is only dependent on one singular point. You don't have to do number line and test both sides. You're just figuring out what's going on at that one point. And so that's why you want to use it for implicit functions. Okay? All right. Let's take out our calculator and do this one together, because we're going to use the second derivative test to do this one. Alex, can I have that calculator back so that I can use it on the thing?
Do you remember?
Because I haven't taught you derivatives of trig functions yet, so we're going to go and I'll show you how to do it with your calculator. So first thing I want to do is I want to find where my first derivative equals 0, right? So since this is if you don't know how to take the derivative or you are allowed to use a calculator, then what you would want to do is this. Okay, so you plug this equation in y1, not in y2. Everybody in? Stop me if you're not in. Okay.
Oh, wow.
Now, if you want to keep it and save it for a long time, go down to like y5. So you give yourself some space. Yeah. Well, I don't graph the integral ever, but derivative, yeah. And let's go, how do we get the derivative again? Math 8. d dx. And then we're going to pull y1, so alpha f4, and get y1. Now, you have to type in x equals, and you have to type in x, so it calculates every single little pixel, which is annoying. It's going to take a while, but that's fine. Now go back up and turn y1 off, so that we're only going to see the graph of the derivative. And we will change our window to go from 0 to 2 pi. Okay, anybody have questions or need help? Just go to window, and x min should be 0 and x max should be 2 pi. Are you in? Yes?
How do you turn off the function?
Oh, how to turn it off? You go back up and you highlight over this equal sign and you press enter and you wait until it's like not have that square, you know, when you move off of it. Okay. Okay, should be graph for you. Everybody good? All right, so we want to know where it equals 0. So we are going to do the, somebody find me this one, and I'll find this 0. So second calc 2, 0. I'll find this one, you find that one. Okay. What did you get? Okay, don't move your cursor. What did you get? 5.234? 235. Okay, cool. Everybody okay? Yes? All right, so we got those two x locations where we have the first derivative equals 0. Now all I want to find is my second derivative at 1.047 and my second derivative at 5.235. So here's what I do. We go to our home screen and we go Math 8 and it says d dx. Now let's go, where was our first derivative? In y, where did I put it? Oh, y5. Okay, yeah. So let's get y5. And then mine is x equals x. You type in your x equals x2 because that number's in there. And you get me your number. What's your number? Negative. You got 8662? Okay, cool. So this one means that at 1.047, I have a relative, okay, so 0.866 is concave up. So I have a relative min at 1.047. And I have a relative max at 5.235 because this one's concave down and a vertical tangent, horizontal tangent line, so I have to have a relative max there. Okay, and then if you want to find the y value, it's already in y1, so I can just do y1 with my intersection in. So negative 0.342. Did you do it with yours?
Yeah.
Okay, cool. Good? Does that make sense to you guys? So you see, this one you didn't have to do a number line. We were using just one singular point. So that's why you want to do it for implicit functions, not for implicit equations instead of the first derivative test. Okay, here's your challenge, is to do number 5. Since it's an implicit function, it already gives you the first derivative. It says find the second derivative. This one I'll help you with once you find A, and then I'm gonna see what you say for C, and then it should be fire drill time after that. Did you get that? Okay, now the curve is going to be concave up when this is what? Positive. So all we have to do is write 1/2 x plus y minus 1/2 has to be greater than 0. And that's a good enough description. It's an equation. Any x and y that fits into that equation will be concave up. Okay? All right, now it's saying that here's why. Does f have a relative max, relative min, or neither at x equals 0? So what do we need? We need the first derivative, and we need to see what happens at 0, 1. So if I plug in 0 and 1, I get my first derivative equals 0, right? That means I've got a horizontal tangent line. Then I have my second derivative. And I'll plug in 0 and 1 in that. What do I get? Positive 1/2, right? Yes? Are you with me?
Yes.
Okay, so that means that I'm concave up. So I've got a horizontal tangent line and I'm concave up, which means that at 0, 1, it has 0, 1, I have a relative min because dy dx equals 0 and the second derivative is greater than 0. Then you have a relative min by the second derivative test. Okay? Got it? All right, cool. We're done for today. Now, we all meet